This is AP Calculus ABA, Unit 6, More Derivatives, Lesson Lesson 2, Applications of the Chain Rule. So last lesson we learned about the chain rule, a very powerful and very well-known rule of differentiation, one that you definitely want to practice quite a bit. And so that's kind of the goal of today's lesson, is to give you a chance to practice using the chain rule to find derivatives. Okay, on the screen I have in Desmos a function that was actually given in your lesson, Engineering in the Chain Rule. This it says, for example, suppose the position of a rod in an engine with respect to crank angle can be calculated using the function x equals r cosine A plus square root L squared minus r squared sine A. So what I've done is I let L and R both equal 1 to greatly simplify the process of finding the derivatives. I could leave them in the function, and that would be an interesting problem, but longer than we have time for right now. Instead of x and a, I'm using f of x, and instead of a, I'm using the independent variable x so that Desmos can recognize it. As you can see, the shape of the graph is repetitive, as is common with trigonometric functions like sine and cosine. So we have a definite period of repetition. It's going to repeat every 2 pi, which is about 3.14 times 2, or about 6.28, and you'll see it does repeat about that often. But what we're interested in doing is answering some questions about, say, for example, what is the rate of change of the position, horizontal position x, with relation to the angle of rotation of the torque arm, or the crank angle. And so, and I'm going to use a specific value at pi over 6. Okay, and so let's find the function value at pi over 6. So our function is, again, f of x. F of x equals cosine x plus square root 1 minus sine x. Okay, and I'm interested in finding f of pi over 6. So unit circle is going to play a big role here. Cosine pi over 6 plus square root 1 minus sine pi over 6 square root. Okay. All right, let's use the unit circle here. So I'm just going to draw the triangle with radius 1. Pi over 6 corresponds to 30 degrees. So it's the 1/2 and root 3 over 2 side lengths. This is sine pi over 6. And this is cosine pi over 6. Okay. All right, so cosine pi over 6 is going to be root 3 over 2. 1 minus sine pi over 6 is 1/2. Okay, so we have root 3 over 2 plus 1 minus 1/2. Square root is square root of 1/2, which is 1 over square root 2. If I rationalize the denominator by multiplying root 2 over root 2, I get root 2 over 2. So this can be simplified to root 3 plus root 2 over 2. Okay, and let's go back to Desmos and verify that that works here. So I'm going to put in the point pi over 6, comma, square root, what was it? Square root 2, square root 3 plus square root 2 over 2. Yeah, and that does lie on the function. So we verified that that's the correct output value for that input value. So we're looking for the rate of change of the x position given the crankshaft angle. Okay, or dependent on the crankshaft angle. How fast is the x coordinate changing? Okay, in other words, the slope of the line. So let's see what we can do here. So let's take the derivative. So I'm going to switch colors here. We're going to go f prime of x. So the derivative of cosine is negative sine. The derivative of the square root. Okay, I'm going to derive this here real quick. I've done this before, but it's worth repeating. This one repeats enough that we kind of want to get a handle on it and not have to derive it each time. It's the same as the derivative of x to the 1/2. Okay, using the power rule, the derivative of square root x then is 1/2 x to the negative 1/2, which is 2 root x on the denominator and 1 on the top. So 1 over 2 root x. Okay, so the derivative of square root is, so let's write it out here. It's positive 1/2, yeah. So we get plus 1 over 2 square root of 1 minus sine pi over 6. Clean that up. Pi over 6. Okay, and now the chain rule says, now we're going to multiply by the derivative of sine pi over 6. Okay, and if I multiply over here by whatever that is, that's the same as putting it up here. So I'm going to put it on top. So the derivative of negative sine, and I put pi over 6, sine x. Sine x. The derivative of sine is cosine. Derivative of sine is cosine. So the derivative of sine is cosine, but this is the derivative of minus sine, so that's going to be negative cosine. And instead of putting it down there, I'm going to put it out in front here. Negative cosine. Okay? All right. So there's our derivative, and we can fool with it and try to simplify it, but there's nothing we can do to really do a lot to simplify it. So f prime of pi over 6 now. So that's going to be negative sine pi over 6. Pi over 6. Minus cosine pi over 6 over 2 root 1 minus sine pi over 6. Okay, and let's see what values that. Sine pi over 6 is 1/2, so this is negative 1/2. Cosine pi over 6 is root 3 over 2. 2 root 1 minus sine pi over 6. Sine pi over 6 is 1/2. Okay, so that equals negative 1/2 minus 1 minus 1/2 is 1/2. Square root of 1/2 is 1 over root 2, or root 2 over 2. Root 2 over 2 cancels with the 2, so root 2. Root 3 over 2. Okay, and so we get negative 1/2. Negative 1/2 root 3 minus root 3 over 2 root 2. Okay. Yeah, making sure that that's right here. Yeah. Okay, let's see if we can simplify this here. I'm going to multiply top and bottom by root 2 over 2, so 1/2, negative 1/2 minus root 3, root 2 is root 6 over 2 times 2, or 4. There we go. Get a common denominator, so this is negative 2 minus root 6 over 4. Or you could say negative 2 plus root 6 over 4. if you put the negative out in front. Okay. Yep. All right, so there's our derivative. There's our derivative. Okay, that's our slope. So now we're going to use the slope-intercept form of a line. Not the slope-intercept, the point-slope form of a line. So we have our input, right, pi over 6, and our output, root 3 plus root 2 over 2. And we've got our slope right down here. So there we go. So let's do it. Y minus the y value, root 3 plus root 2 over 2, equals the slope, negative 2 plus root 6 over 4, x minus the x value, pi over 6. Okay, and we could go ahead and change that to slope-intercept if we want, but that's kind of an academic concern. Desmos will graph it just fine, so your TI-84 won't. Square root 3 plus square root 2 divided by 2 equals negative 2 plus square root 6 over 4 times x minus pi over 6. Okay, and not interested in having that be the same color. There we go. All right, and it seems to do what it was supposed to do. It goes through the point, right, that we gave, and it is tangent. If we zoom in, it seems to touch that function right there, only there. Okay, so that is tangent. Now you're also asked to find the normal, or the perpendicular. Normal means perpendicular. There are several words that mean perpendicular. Normal, perpendicular, right, and orthogonal. They all mean the same thing. Orthogonal means perpendicular as well, but they're going to use the word normal. Normal is usually used in the context of physics. So when we're talking about motion, we often talk about normal, normal to the surface, for example. Okay. In order to find the function that's normal, that's really kind of a simple little thing. I'm just going to copy this function. And I'm going to insert, instead of negative 2 plus root 6 over 4, I'm going to flip that and take away the negative. Okay? So let's take away the negative and flip it. Put the 4 on top. Put the 2 plus square root 6 on the bottom. And there we have it. And not interested in it being the same color. How about green? There we go. Okay, and we can see that it is perpendicular. Okay, so normal is the negative reciprocal of the slope. All right, so hopefully that helps.